Good morning there, welcome back. And you have started watching video on Introduction to Machine Learning. And this is lecture number 5. And we are discussing different types of learning procedure. Today we'll discuss, let us start our journey. But before that, I would like to tell you the name of some reputed companies who are actually investing a lot of resources in AI research and development. Development means product also they are developing. Some of the name, these companies, as you know, well known, and maybe many of you will aspire to contribute there. The companies are DeepMind, Google Brain, Facebook AI, OpenAI, Baidu is a very strong company in China. Microsoft, actually, they are trying to do real-time translation through Skype. And then Apple Siri, they are also doing facial recognition. IBM, they are trying to extract meaning from photo, video, text, and speech. Amazon Alexa, Amazon Go, automated drone delivery. So in this area, Amazon is investing. Okay, so I had an opportunity to go to visit some of the shop in Amazon Go. So their idea is fantastic and especially very good for a situation like this, pandemic situation like this, where nobody can touch you, but you can just enter in the shop and pick up the items and then come out. No billing, nothing is required. Automatically within an hour, the bill will come to your mobile and you can pay. Although I have not seen their cart equipped with robot, maybe that will be for future. Then another company, Nvidia, they are also very strong and they are deeply involved in applying AI in healthcare. Okay. So with this introduction, I would now like to introduce you some of the very useful concept. I may not be very technical because this is a very introductory lecture, but even then the concept is very, very important. So what we are going to discuss now is, you see, the difference between autonomous system and an intelligent system. The system may be a software agent or it may be hardware, like robot. Right? What is the basic difference between them? So autonomous robots actually are top-down. Autonomous agent works on top-down approach. That means everything should be planned properly, and they may not be intelligent. Okay, they may be, but may not be. An intelligent system, they are allowed, it's a bottom-up approach, they are allowed to learn from the environment, okay, and in a layered way and can take decisions, okay. I may give you some example to illustrate which is an autonomous system, which is an intelligent system. Then again, I will take the example from software domain. Say big softwares like railway reservation software in India, or flight reservation booking software, or maybe any such software, right? Or banking software, the software which actually are processing your transactions and giving you balance, everything, right? They are basically autonomous type of software, right? So at the back end, they have huge table and whatever may be the data size, they are keeping them very structurally. And in the front end, there are some user interface through which you can fire query. For example, again, reservation software, railway reservation software. So you fire query that in a particular day, in a particular train, in a particular class, how many seats are available, and whether you can buy a ticket or not, availability is checked, right? And immediately they will give the availability, right? So so this is not an intelligent software. Or banking software, right? Where they are maintaining all the transactions they are processing, they are maintaining your balance, right? So if you withdraw some money, automatically that will be debited from your account. If some fund is coming, it will be automatically credited. You will get a statement. All these are happening. They are using maybe huge software, and um, but they are autonomous software, right? Not intelligent. Now take an example that in a particular section route, okay, in a particular time you analyze, you collect data, lots of data, right? Say in a particular section, whether the trains are overloaded or the aircrafts are overbooked, okay, in a particular section or route, and month after month you collect previous data and analyze the data, okay, and try to figure out, try to make a decision that whether you need to introduce a new train or new flight in that particular route to for the comfort of the passengers because it is highly crowded, or the other way around, whether you could withdraw a train or a flight if passengers are not there. If this kind of decision you are taking based on your past data, you make a model, and from the model you are trying to take the decision, okay, so then this is an intelligent example of an intelligent software. Or in a banking example, software example, for example, that uh, you have some credit history, right? Your age, your salary, income group, and all kind of things. The data is there, and bank has designed a software which will help the manager to take a decision whether or not to lend you money. So this kind of decision making, um, uh, uh, decision making can be obtained from softwares. Then those softwares are intelligent software. So I hope you understand the difference between these two. It is neither the amount of data it is handling, neither the size of the software, but it is the action, what kind of action it is performing. Based on that, we can call a agent autonomous agent or an intelligent agent. So to become an intelligent agent, there must have some learning from the data. Okay, so this is the basic difference between these two, and there are different types of learning. Four of them are very common. Among four, these two are extremely common and we are using today: supervised learning, unsupervised learning. Okay, as the name suggests, supervised learning means just like your parents teaching the baby or the child what's to be done, what is not to be done, in what situation, what action to be taken. So, in a supervised way, or a teacher teaching her students how to take some action, how to do the things in a continuously supervised way. This is called supervised way of learning. And if the child or the student learn in turn to take their own decision in some area for which it has been trained, that is an example of supervised learning. So the idea is clear, right? And then unsupervised learning means there is no teacher or no parents kind of thing, right? So you have data, and seeing the trend of the data, you are somehow um, define an algorithm which is helping the system to learn. So this is called unsupervised learning, right? So this is very predominant in the industry. I should say 90% of intelligent system, they are taught using supervised learning method. and unsupervised learning method is coming up very rapidly. It is coming up. Okay. um, so, and then other two type of learning is reinforcement learning and taskful learning. I will discuss this in a as far as possible non-technical way so that you get the concept. Now, before doing that, let us try to understand the difference between this supervised and unsupervised learning. So, we'll compare in terms of input data, computational complexity, and in terms of accuracy. So, in case of supervised learning, the algorithm are trained using labeled data. This is very important to note. It's labeled data. For example, if it is handwriting digit recognition software I am making, right? Then I need to have a very well-structured past data about different kinds of digit 0, 1, 2, 3, 5, written in a different way. Okay, and those are to be labeled. Means there may be some few hundred zero. So this is 0. I know. Few hundred one, different types of handwritten one, few hundreds, 2, 3, 4, 5, 6, 7, like that. Okay, so each class, we are calling class. Okay, because if it is a classification problem, handwritten digit recognition means I will write something and computer will understand, taking the image uh, from the camera, my shape of the handwritten digit, and you know why it is challenging, because everybody's handwriting is different, right? So uh, you need to have a software which has this learning, okay, a priori. So in this case, I have given an example. There could be 10 classes, 0, 1, 2, 3, 5, 6, 7, 8, 9. And for each class, you need lots of data so that the algorithm, algorithm can be trained using those data. And those are to be labeled data. So this is the meaning, right? That while training the algorithm, I must tell that, okay, this is 0. If this is the shape, output should be 0. If this is the shape of the handwritten digit, output will be 1, like that. So this is an example of label data. Whereas, by the way, this is very good to say, but getting label data, especially when you require, say, 100,000 datas, okay, in a particular domain, is very tedious and difficult, okay. On the other hand, unsupervised machine learning technique, they do not need labeled data, right? Data is enough, okay. Uh, and then in terms of computational complexity, supervised learning is much more simpler method, okay. Whereas this is computationally complex, okay. So unsupervised learning are computationally complex. And in terms of accuracy, this is highly accurate, supervised learning. Okay, supervised learning based algorithms or the softwares are much accurate than unsupervised um, uh, way of learning algorithms or softwares. Okay, so these are very important. The recent happening, some example I can give. I gave an example of handwritten digit recognition. It can be character recognition, A, B, C, D, like that. So same. Okay. Or this is an example of supervised machine learning technique. Okay. Suppose you have some data, or it could be housing price data. You see, let us small example that housing price is not so simple, but just for simplicity, you assume housing price depends on how big the house is, and we characterize it by floor area, right? So you collect data, say floor area, and this is cost. Okay, so it is x1. Say this is x2. Okay, and you have collected so many data, right? If this is a flood area, this is the cost. This is a flood area, this is the cost. So a priori data is needed. And then you are making a model. Incidentally, this is called regression model. A regression model. A regression model is developed for seeing the trend of the data. Okay. And from the trend, you can make prediction for the region for which data you do not have the data, right? Suppose seeing the trend, you just fitted a kind of predicted like this, okay? Say, just I have given an example. So this is a function, this is straight line, and this is your parameter, 1, 2 parameter, okay? And then you have make a model, and this data will help you to know the values of this parameter. Learning means all about that, okay? So with a simple example, I gave to illustrate that what is the meaning of learning, okay? Or it may be some kind of neural network example, okay? uh, don't worry about this, we will talk about all this in much more greater detail. Okay, say you have inputs x1 x2, you have output, right? And you need level data. Here also you need level data. Past data means this floor area house cost is this. This floor area house cost is this. Or here, for example, I am trying to make something that if x1 is this, uh, I can make a table kind of thing, and then y. If both of them are 0, then this is 0, for example. This is, if one of them is 1, then it is 1, okay? And then when both of them 1, then again it is 0. Say, I am taking an example. And I am making a model so that it will learn this pattern, and it will afterwards it will predict, okay? So again, those are my parameters, okay? This weight, okay? These are called weight parameter. So level data means this data, prior data are leveled, okay? What will be the output for what combination of input, okay? On the contrary, suppose you have some classes, right? X1, X2, and then, okay, and you are trying. So these are your data, not level, okay? Some data you have, and you are trying to classify that which data belongs to which class. Say this is one class, this is another class, okay? So example of supervised learning will be regression, will be say neural net based classification problem, or regression, logistic regression as a classifier. All these model we will study in greater depth. They are all example of um, uh, model which learn with the data using supervised way, okay? On the other hand, say k nearest neighbor or clustering, simple clustering. So what I have done, I have some values data, and I have calculated the distance of each data from other data. And then I have made a threshold, for example, who are very closer to this class of data. So I am classifying, okay, whoever is within this threshold, they belongs to this class. Whoever is between this threshold belongs to this class, like that. Okay, so this is an example of model which can be which can learn using unleveled data in an unsupervised way. It can learn, okay? However, this is a very active area of research now. Thanks to deep learning, many generative models are coming into the picture, so that the you don't need level data for training a network, because in case of solving big problem, you need a gigantic network, you need millions of parameters, you need millions of data, and who will supply those level data, right? And you will be surprised, there are companies now, and especially those companies are located in a remote village in developing nations, because those jobs are so boring, okay, to level or put a tag to the data, right? Millions of data are there. So some companies are there only to make the leveling of the data, okay, because they want to make a model using supervised learning method, because they are very accurate, comparatively accurate, and computationally comparatively friendly. Okay, so we have another two. These are two common. That's why I spent some time. Another two algorithms are there. Learning strategy. Sorry, not algorithms. Learning strategy. Reinforcement learning. Actually, this is based on not either supervised or unsupervised, right? So an agent is allowed to do mistake, right? Say, think about a drone, okay? So it is trying to fly. So it's, and flying related parameter, that means the speed of the fan, okay, and which is creating thrust, and motor torque, all kind of thing. An example I am giving. So those parameters somebody is noting down. Now it is allowed to fly. So it will try to fly, and randomly when it will try to fly, for some combination of the parameter it will be able to fly, for some combination of the parameter it will actually it will fall. So noting down those parameters corresponding to the states, we uh, assign a reward, okay, or penalty, and then there are algorithms for that, okay. So Q-learning, for example, is an algorithm. And when you have used such data, you collect huge data and try to figure out and parameters which will give you optimum values of the parameter, which will correspond to this stable flying. So now parameters, after learning from failure or learning from mistake, okay, after learning, those parameters will be fixed, which will be conducive for stable flying, and this will drone will fly. So why this reinforcement learning technique came into the picture? Because in many cases, making very perfect model is very difficult, and when you cannot make the model, controlling such system becomes difficult. And if you uh, use this strategy, as I discussed, reinforcement learning, award, reward and penalty, and then formulate an algorithm, okay, uh, then it learns in that way. Another very interesting learning strategy which is coming up, and still people are doing research, is known as transfer learning. The concept I am going to tell you, okay. Say you are students, engineering students, right? And you are spending 4 years in learning computer science and then different subjects and all kind of things. Before that, you also studied high school, okay, and physics, chemistry, maths, all kind of thing you learn, okay. So, mostly in the supervised way, sometimes unsupervised way, and in a combined supervised and supervised way, you learned and you develop certain skill, okay. Now after 4 years, we successfully, if you pass, then we give you a degree, and with that degree, through campus you get placement, okay. And the company who is hiring you um, may deal with some uh, technology or something which exactly you are not taught, right? So what they want to do, they want to give you some 1 month, some 6 months, or 1 year training, in-house training, exposing their particular technology, and they are relying on your background which you have. So they are trying to transfer the learning, 4 years of learning, by spending additional 6 months to make you capable of handling their job. So this is an example of transfer learning. Now, in actual domain, suppose I have a giant neural network which has been already trained with millions or billions of data in a particular um, uh, environment, and then those parameters, trained parameters, are already known, and I am trying to make some minute changes of the parameter in applying that same neural network in solving my own problem. This is called transfer learning. I am transferring the learning which the network already had, or I try to explain, or student they already have. I try to explain with this small example. I think you understand what transfer learning is. Don't worry, we'll actually take up this learning algorithms afterwards also in your deep learning course. And in machine learning course, reinforcement learning will be taught, especially the Q-learning algorithm. Okay, so reinforcement learning, uh, transfer learning, they are data hungry. Means lots of data are needed. So that's why they are finding, especially reinforcement learning is very popular in game design, um, where synthetically you can generate lots of data which can be used for training. Okay. Now, having said all these things, now background is ready. We are now slowly will take you to a particular um, uh, training you in particular tools and techniques, right? So introduction is over. So now suppose I will conclude by telling you, suppose you need to develop a machine learning model, okay, and you have data. Then what next? What you do? First, you need to make training with the data, right? Training means what? That I gave an example of simple, uh, say, 2D case of simple example of regression. Okay, housing price, right? I will do regression analysis to see the trend of the housing price, and that will act as a predictor. So this is called regression problem, and the other one is called classification problem. Say you have face image or digit and digit data, and you are trying to classify which one is what, which one is 0, which one is 1. So these are called classification problem. However, the general model development techniques remains the same. Just see, suppose you have collected data, past data. Okay, these are your data. Then what you need to fit a curve. Okay, say x is the feature. I say I decided, this is my decision, right? I will feed a straight line. So I need two parameters which are unknown to be fixed. And this is actually called learning. Through learning from the data, this parameter will be fixed. And how we'll discuss, right? But right now you should know that for determining this parameter, you need an object. So data in the sense that so you have for this x1 value, what should be the x2 value, you know, right? So these values are known, so you can calculate, but you are telling that no, for this x1, this will be my x2 value. So you are incorporating, you are generating a function. Say I am naming this function, Okay, you can generate a function from very basics, and now this is actually is difference is a function of um, error. Error is what means you have actual value corresponding to a particular x, and you have theoretical value corresponding to a particular x. Theoretical value is this. So this will be a function of parameter, right? W1, W2, you will get some value. And then this is called objective function. You have objective function. Okay. Now what? Now to determine W0, W1, you need an optimizer. Means if it is an error function, for example, what is my objective? Objective is to make error as minimum as possible. And in doing so, whatever W or parameter will do this error minimum, that will be my parameter. Okay, and we call jargon term predictor. So once I know this and this, then I say my model is ready. Okay. So you need objective, you need some data, you need some objective function, you need an optimizer. Optimizer actually may be calculus based, right? You can partially differentiate. This could be an optimizer, gradient based optimization we call. Okay. Equal to 0. In doing so, as many parameters will be there, that many equations you will get, right? And solving those equations, you will get this value of the parameter. Okay, so optimizer role is extremely important. Objective functions role extremely important. These are called model building. And once the model is built, you need to test that. Okay, so what is the procedure you follow? If you have this many data, use some 70% data for fitting this curve. Keep other data aside. Once the parameters are determined, predictor is designed, then you use this range data to see, because this data for in this range also for given x1, what should be x2 is known, right? And you can also see from now predictor. So now this is known, this is known. So predictor will tell you some value, and you can see whether they are very near to the value x2 or not. So this is called testing. Performance testing is needed. If you have a good design, then performance, that means the error between during testing, the error will be very minimum. If you have a bad design, then error means predicted value and actual value will be more, and we call you have designed badly. So it's a design. Okay. So learning process is this. Okay. An entire model we have developed a model. Model means we have developed the predictor. Okay. Is a small example. So with this example, I wanted to expose you to the machine learning model development paradigm. And in the next class, I will take you to a particular problem, linear regression model development technique. So one by one, we will now study deeply. There will be regression model, there will be classification model, number of classification model. Okay, so all this model development technique you will know, because no single model will work everywhere. So you need to know several model development techniques, so that you see, his design is just like a carpenter. The more number of tools the carpenter has, more better design in furniture he can make. So with this lighter note, I am concluding here. I am telling, I say you goodbye. Stay safe.